Okay, here's a review problem for exam 1 where you're given a truss as shown in the figure, and then you're given something about the truss. In this particular case, we know that the force in member BD is in compression, and we know its value. Okay, so from there, I want to know the force for members AB and BC. So look on the diagram here. Here's AB, here's BC, and what we're saying is known. I put that in blue. What we're saying is known is BD. All right, so we talked about in class that, oh, this is good. We know this one, and these two are unknown. If we have a joint where there's two unknowns, we can write equations and solve for the unknowns. All right, so I think it's pretty clear. What we need to do is take a look at joint B, just because that's the only joint that involves the known, the given, and the unknowns. All right, so from there, what I would like to see is a free body diagram. Let me make that a little smaller. A free body diagram at joint B. Okay, so we see at B, we notice there's this 2.4 kilonewton force acting down. All right, we know this has been given, and we know it's under compression, so the member is under compression, so there's forces pushing it together, so it pushes back onto that joint. So remember, if it's under compression, the arrow is going to go into the joint. Okay, and so that was given at 4.16 kilonewtons, and it's at the same line of action as FAB. Okay, so FAB is one of the unknowns. All right, and then we see we have this force member FBC, so let's assume it's in tension. I did the same thing for AB. I assumed it was in tension with the arrow coming out of the joint. Okay, and so that's the free body diagram. This would be FBC, and that's a good start for the problem. All right, so the next thing you're going to ask yourself is, well, how would I write sum of equations in the x direction and the y direction? I'm going to need to resolve these forces into those components. And so to do that, I'll need to identify certain angles from the geometry of the problem. Okay, so I'm going to switch the pen to red here. All right, so if I wanted to resolve FAB into its components, if I had the angle alpha, I could get that, right? Because the x component is just cosine alpha FAB, and the y component is sine of alpha times FAB. All right, so I look at this diagram. Can I get alpha? And what I'm thinking here is, oh, I like it because I know the adjacent and I know the opposite, and I know both those values, so I can get that alpha is equal to the arctan of 7.5 over 18. All right, so I think that's pretty straightforward. All right, and you notice, AB and BD are acting along the same line of action, so this is also alpha. So when I'm trying to resolve the 4.16 K Newton force, I can use that same angle to get those components. All right, so then what do I need? Well, let's switch to a purple pen. Then, if I had this angle beta, all right, and if you think about it, this angle beta is the same as this angle beta, all right, because it's parallel lines bisected by a line. Okay, so you know the geometry of that. So I need to find beta, all right? So I'm looking at this triangle here. Let me clear off some of this junk so we can zoom in. All right, I want to know beta right here. All right, if I had this height and this distance, I could get beta. All right, because it's just tangent. All right, so this height and this horizontal distance. Well, I look at what's given. this is a 6, and this is a 9, so it's pretty clear that this is a 3. All right? So if I had H, I could get beta. All right, and what I do have is alpha. I know that number. I've already calculated it. Okay, if this is a 3, this is a 6. All right, so I can come down here and I can figure out tangent of alpha is equal to opposite over adjacent. All right, I know alpha, so I just plug that into here, and I can get H. H is equal to 6 tangent alpha. All right, and from there, from the picture, I then know that beta, the angle beta, is the arctangent of the vertical divided by the, the opposite divided by the adjacent. Okay, so beta is arctan of H over 3. All right, so this is a little harder. You had a little more geometry to do, but once you have that, it's now just straightforward to resolve everything into components. All right, so let's switch again to green. Okay, make this a little thicker. All right, sum of the forces in the x direction have to be equal to 0. All right, so looking at the diagram, I see that for this force, if I resolve that in the x direction, it's going to be minus FAB cosine of the angle. The angle is alpha. All right, next consider this force. It's minus 4.16 cosine alpha. All right, this force is completely vertical, so I don't have to worry about it. All right, and then this would be acting in the positive direction. Okay, so this would be plus FBC cosine of beta. All right, all that has to sum to 0. All right, so that's sum of forces in the x direction, and we do the same thing, sum of forces in the y direction. Okay, for the y direction, we have this minus 2.4 working down. Then we have the 4.16 working down. We take the sine of alpha to get the y component. And then for FAB, that's also working down, so it's a minus sign. Okay, and then for finally we have minus FBC. That's working down, sine of beta. All that's equal to 0. All right, so on an exam, this is a fairly substantial problem. Lots of calculations with your calculator. I would probably ask you more to set this up, write the equations. So this would be what I was looking for, because everything is known. I calculated alpha, that's known. I calculated H, that's known. Therefore, I can calculate beta, that's now known. And the only thing that's unknown in the problem is FAB, FBC, and it's two equations, two unknowns, that I could solve it. Okay, so if you solve it, all right, then it turns out what you get are these numbers. And so because this is negative and I assumed that the members were under tension, that means they're really under compression. Okay, so we know that FAB is 6.2 kilonewtons under compression, and FBC is 2.5 kilonewtons also under compression. All right, so hopefully that helps you as you walk through any kind of truss problem. For a truss problem, you're going to need to identify the important joint. I think the joint was pretty obvious in this case. All right, do a free body diagram at that joint, do a little geometry to identify important angles, and then write sum of forces in the x direction equals 0, sum of forces in the y direction equals 0. And then if I'm just asking you to set things up, you'd be done. And if I ask you to solve things, you know what to do from there too.